Hey guys, so today we're continuing on with polynomial operations. In this case, just the multiplication part, because I want you to see what happens if you can't FOIL. So I'm actually going to do number 6 before number 5. So 3x plus 2 squared. Never square each term. That's not what this means. So anytime a binomial or any expressions have plus or minus signs in them, if ever they're being squared or they have a power, you're going to take the literal definition of an exponent and multiply it by itself that many times. So in this case, twice. Now, since there are only two terms in each parentheses, I can still keep my method of FOIL. So again, first, outer, inner, and last. So first, I'm going to multiply the first term in each parentheses, 3x times 3x. Remember, this each has a power of 1. So I'll write that out first. 3x to the first power times 3x to the first power. This would give me 9x to the second power. 3 times 3 is 9, and x to the first power times x to the first power. When multiplying like basis, I add the exponents. Outer, or the 2 on the outside, 3x times positive 2. So I have 3x times 2, positive 2, which would give me positive 6x. Here, inner, I'm taking the 2 on the inside, positive 2 times 3x. So again, 2 times 3x, which would give me positive 6x. And then last, the last one in each parentheses is 2 times 2. So 2 times 2 would just give me a positive 4. And then when I'm done FOILing, I've pretty much done the multiplication part. All that's left is adding and subtracting, so I'm going to look for like terms to combine. There's nothing with x squared, so we bring that down. But we do have positive 6x, which would give me 6 plus 6 is 12, and I keep the like term of x. And then the 4, there's no like term as well. This is the only constant, so I bring that down, and that's it. Now, what happens if there's more than two terms in each parentheses or in one of the parentheses? FOIL no longer works. You have to use what's called the distributive method. So if you look at number 5, the second parentheses has 3 terms. Terms are separated that by plus and minus signs. So 1, 2, 3. Can't do FOIL. FOIL only works when you're multiplying two binomials together. Binomials meaning two terms in each parentheses. This is a trinomial because it has 3 terms in this second parentheses. So a binomial times a trinomial, you can't do FOIL anymore. You have to use what's called distributive property, meaning I am going to take the first term in the first parentheses, which is 7x, and bear with me, I'm going to put to the first power just because I know I'm going to multiply. And I'm going to multiply it by everything in the second parentheses. I'm not actually going to multiply it yet, I'm just going to set up my problem. I also take the next term in the first parentheses, and I also multiply it by everything in the second parentheses, which is, again, 5x squared plus 4x plus 1. Now keep in mind, I only started a new line because I'm out of room here, but this should all go together. So I'm going to do this step by step, and I'm going to distribute 7x to everything in the first parentheses. So 7x times 5x squared would give me 35x to the third power. Remember, I'm multiplying, so I'm going to add those like basis exponents. 7x times 4x. These each have a power of 1. 7 times 4 first is 28, and then x times x is x to the second power. And then finally, 7x times 1 is just 7x. And then from here, minus 3 times 5x squared would give me negative 15x squared, and I'm out of room, so this is a continuation, but I'm just going to go to the next line here. Negative 3 times 4x is negative 12x, and negative 3 times 1 is negative 3. So once you're done distributing, it's just like FOILing. You're done with the multiplication process. You are now looking for like terms to add and subtract. So we look at 35x to the third power. There's nothing with x to the third power. We bring that down. We have 28x squared. So if you look, you have another term with x squared here, and we're going to keep the x squared and just do whatever the coefficients tell us. 28 minus 15 would be positive 13, and then bring down the x squared. We have 7x, that should be a different color, sorry, 7x, and it matches with negative 12x. So I have 7 minus 12, again, signs don't match, so I subtract 12 minus 7, which is 5, and I take the sign of the bigger number, which is 12, and that's a negative, keep the like term. Their like term is x. And if I look at the last one, I have a minus 3, which is a constant, meaning no variable next to it. It's just always going to stay negative 3, but there's no other constants to combine it with, so I just bring it down, and that's pretty much it. All right, guys, hope this helps.